In the previous lecture, we defined the iOperations interface. And we mentioned that an interface can allow us to add functionality to a class that comes from many sources, for example, one class and multiple interfaces. Because we also mentioned that inheritance can only be done from one parent. A class cannot inherit from multiple classes. So for example, what happens if we want to create a new class? I'm going to create another class inside of the program file that is advanced math. Now this is just the name. We're not really going to be doing any advanced math, but this advanced math is going to be inheriting from simple math, and it's going to have its body. By inheriting from simple math, we already know that it's going to have access to its 4 members, its 4 methods. And right now it's going to do the exact same thing as the simple math. But this new class is also going to implement the iOperations interface. Now, to implement from an interface, we have the same notation that we have when inheriting from a class. If we were inheriting from simple math, in the case of the advanced math class, we could implement by just writing colon and writing the name of our iOperations interface. Right now, though, we are inheriting from this class, so all we have to do is add a comma and then write the iOperations interface. And now the class is going to be both inheriting from a class and implementing, in this case, one interface. Now notice that right now you have an error. And that is because as soon as you add a definition for an implementation of an interface, you absolutely have to implement all of its members. And right now, we are not implementing its members. And notice that we have a member to implement, the remainder method. To implement this method, all we have to do is place our cursor on the name of this interface, which we are going to be implementing. And in the case of Visual Studio, we have the option to right-click and select Quick Actions and Refactorings. In Visual Studio for Mac, you will see a similar option that you can access through Alt-Enter. In the case of Windows, you can access this by Ctrl-Dot. And notice that you see a list of options that you can do in order to solve this issue. And this works for any number of errors that you may encounter in your code as well. Right now, the option that we want to select is the first one that says Implement Interface. And we have a sneak peek of what is going to happen once we implement the interface. So let's press Enter and notice that now we have the implementation of the method. Remember that in the past lecture, we made the distinction between the definition of a method and the implementation of the method. So inside of the interface, we only see the definition of the method. On an interface, we cannot implement functionality. That functionality is going to be the responsibility of the classes that are going to implement this interface. In this case, we are already implementing the functionality. Right now is just throwing some exception. We do not want this line of code. What we want to do is return the remainder of a division. On C#, this is as easy as writing the dividend, then the percentage character, and then the divisor. Just like this, our remainder method is going to be returning the remainder of the dividend divided by the divisor, as well as having access to all of the 4 members from the class it is inheriting from. So let's go ahead and test this remainder operation. We can go ahead and test it inside of our main method. To use the advanced math class, we do need an object. So we're going to create a new object of type advanced math. That is just going to be AM. That is going to be equal to a new advanced math object. And the AM object now has access to the remainder method. And from that remainder method, we can, for example, divide 7 by 3. And we will get the remainder, of course. And what we want to do is display the remainder inside of the console through the WriteLine method, just like this. And meanwhile, I can comment all of this code that I have in here. To comment a block of code, all I have to do is add a slash and then an asterisk. And then to close this comment, I add the asterisk and the slash. And so this block of code is now commented. So I can run this on the console. And as soon as it is open, I can see the first line still refers to the first line of code that I have, which is doing a division, but the second line does show the remainder of dividing 7 by 3. So we can see that we now have an implementation of our remainder method that was defined inside of the iOperations interface. Another thing that we can do in here is define the IM object actually as iOperations. And in this case, this definition can then have any value as long as it is assigned to a value that implements from iOperations. So for example, I can have the definition of AM at class level and then inside of the code assign it to something. For example, I can have the definition of the AM variable at class level and then define its value from within the code. And this variable can be assigned to any new object as long as the class is implementing the iOperations interface. This could be useful when we don't really know what type the AM variable is going to be, but we do know that it has to implement this interface because we're going to be using the remainder method. And so then we can be certain that we can use the remainder method because if the class is implementing the interface, it absolutely has this method without worrying about the actual type that the variable is going to have. Of course, depending on the value that the variable is going to have, it is going to use that method. In this case, it's going to use the implementation of the remainder method that is inside of the advanced math class. So we're closing in into the end of this section, but still we have to talk about something very important. Now that we have learned about how we create interfaces, how we have definition of members, how we implement those interfaces and their members, and how we can use them, in the next lecture, we're going to talk about asynchronous programming.